Hi everyone. Today we're gonna work with this problem. Is This is an integral problem with summations inside the integral. Okay, so we can work with the expression inside the integral first. So we get 1 over x minus 1 plus summation from k equals 0 to 2018 of k plus 1 x raised to the k power over summation from k equals 0 to 2019 of x to the k power. Okay, so since we want to add two fractions with different denominators, we need to multiply the denominator and do the cross multiply. So here we can cross multiply here and multiply here. So that'll be summation from k equals 0 to 2019 of x to k power plus x minus 1 times the summation from k equals 0 to 2018 k minus k plus 1, sorry, x raised to the k power. Then it goes a fraction, and then at the bottom we have the multiplication of the denominator, so it'll be x minus 1 times summation from k equals 0 to 2019 of x raised to the k power. Okay, cool. So now we can distribute on the top here. We can distribute the x to this expression and the negative 1 to the same expression. So get I'm going to use this color here. So summation from k equals 0 to 2019 x k plus. So if we multiply x, we have x summation from k equals 0 to 2018 k plus 1 times x to the k power. And if we multiply the negative 1 part, we're getting negative 1 times that, so it'll be negative summation from k equals 0 to 2018 of k plus 1 x to the k power. And then it goes to fraction, and on the bottom we can distribute. So distribute x and distribute negative 1. So we have x summation from k equals 0 to 2019 of x to the k minus summation from k equals 0 to 2019 of x to the k. Okay, perfect. So since the variable that changes on the summation is determined by this, for example, if we take this summation here, the variable that is changing constantly is k. So x would be a constant. So a constant can be written outside the summation or inside the summation. So for this problem, I want to write x inside the summation. So there'll be, we copy the first term, which is this, and then we put the x inside the summation. So since we have x here and x raised to the k power, the exponents added up, so there'll be x to the k plus 1. So there'll be summation from k equals 0 to 2018 k plus 1 x to the k plus 1. And then here we can distribute inside the summation. We can distribute xk here and xk here. So we have summation of k equals 0 to 2018 of k x to the k minus summation for k equals 0 to 2018 x to the k. And the denominator would be the same. We can do the same at the denominator, so this x can be inside the summation, so there will be summation from k equals 0 to 2019 x to the k plus 1. And here we have summation of k equals 0 to 2019 of x to the k. Okay, cool. So basically we're getting this expression, and now we're going to analyze the sigma notations here. For example, we need to remember how to change the variable with sigma notation. So I'd like to change the variable here. We can change the variable and the limits here. So I'm going to call this a. So for a we have the summation from k equals 0 to 2018 k plus 1 to x plus 1. Okay, perfect. So if we want to change the variable here, we can change by m. I don't know, m equals k plus 1. So we have to change the limits of this summation. So we have k equals 0. When k equals 0, we have m equals 0 plus 1, so there'll be 1. And when k equals 2018, m would be 2018 plus 1, so there'll be 2019. So changing the variable, we're getting a new expression for this. So there'll be summation from m equals 1 to 2019 of m x to the m, right? Okay, but since m is a variable that constantly change, we can use the original variable here. It's the same. K x to the k. So this would be the expression for a. This is the new expression for a. Okay, cool. And we can do the same with this. Let me show you. With this expression, this would be b. So for b, we have the summation from k equals 0 to 2019 x to the k plus 1. So we can change the variable again. So changing the variable, m equals k plus 1. So when k equals 0, m would be 0 plus 1, that'll be 1. And when k equals 2019, m would be 2019 plus 1, that'll be 2020. So the new expression for this would be the summation from m equals 1 to 2020 of x to the m power. So we can use the original variable here, so we can use k from k equals 1 to 2020 of x to the k. And this would be the new expression for b. Okay, perfect. So we can continue working on the fractions. So we have summation from k equals 0, 2019 x to the k. The new expression for a would be summation from k equals 1 to 2019 of a kx to the k, then minus summation from k equals 0 to 2018 of kx to the k, minus summation from k equals 0 to 2018 x to the k. And then it goes to fraction, and then we have v, which is summation from k equals 1 to 2020 x to the k, minus summation from k equals 0 to 2019 of x to the k. Okay, perfect, cool. So as you can see, we have similar terms in this fraction. Okay, so we can work with these terms here. We call this could be 1, okay? So what happened with 1? So 1 would be summation from k equals 1 to 2019 k x to the k, minus summation from k equals 0 to 2018 kx to the k. So as you can see, we have different limits on this. So there is an easiest way to solve this problem, which is drawing. So I'm going to use color yellow for the first sigma notation. So we can represent that like a bar here. So we start with 1 and end with 2019. And we can use green here for the second sigma notation. So we start with 0, so 0 would be here, and we end with 2018, something like this. 0 and 2018 here. Right. So as you can see, we're subtracting the same terms on these areas. We're subtracting here. So we're cancel these terms out because we have common terms here. So basically we're getting here just the last term for the first sigma notation, which is 2019 x plus 2019. And for the second sigma notation, we have the first term, which is 0 for k. So there'll be 0, x to the 0 power, so there'll be 0, right? So basically, this would be 2019 x to 2019 minus 0, which is 2019 x to 2019. And we can do the same with the others. For example, for this and this, we call 2. So for part 2, we have this. For part 2, we have summation from k equals 0 to 2019 x to the k power minus summation from k equals 0 2018 x to the k power. Yep, cool. So here we can use the same methods. I'm going to use yellow for the first sigma notation. So we start with 0 and we end with 2019. And for the second sigma notation, I'm going to use green. So we start with 0 and end with 2018, right? So that'll be here. 0 and this is 2018. So we are subtracting here. So as you can see, we have the same terms here. They cancel each other out. And we get just the last term of the first segmentation, which is when k equals 2019. So that'll be x to the 2019. Okay, perfect. And we can do the same on the bottom for this and this. So I'm gonna let this as 3. So for part 3, we have sigma notation of k equals 1 to 2020 of x to the k minus sigma notation of k equals 0 from 2019 of x to the k. So I'm going to use yellow for the first segmentation. We start with 0, 1, and we end with 2020. And for the second, I'm going to use green. So we start with 0 and end with 2019. 0 and 2019. And we are subtracting them. So we have the same terms in these parts, so they cancel each other out. And we just get the last term of the first segmentation, which is when x equals 2020. So there'll be x to the 2020. And on the second segmentation, we're just getting the first term, which is when k equals 0. So there'll be x to 0, which is 1. So this would be x to the 2020 minus 1. X to the 2020 minus 1. Okay, cool. So now the final fraction we're getting is 2019 x to the 2019 plus x to the 2019 over x to the 2020 minus 1. And this would be 2020 x to the 2019 over x to the 2020 minus 1. So now we have to use the integral sign here. So that'll be 2020 x to the 2019 over x to the 2020 minus 1 dx. Okay, perfect. So as you can see, if we derivative this part, we're getting 2020 x to the 2019. So basically the derivative of the part of the bottom is on the top, so this would be the same to write. Integral derivative of x to the 2020 minus 1 over x to the 2020 minus 1. And this would be natural log of x to the 2020 minus 1. And don't forget to add a constant, because this is an undefined integral. That's it. This would be the final answer for this problem. Final answer. Have a nice day, everyone.